All right, we're going to take a look at a couple terms that you'll need to know moving forward, and they are perpendicular bisector and angle bisector. So starting off with, a perpendicular bisector of a segment is a line, segment, or ray that is perpendicular to the segment and divides the segment into two congruent segment parts. So first of all, you'll notice this word perpendicular right here. So that's going to be important. Oops, that's not what I wanted to do. I'm sorry, guys. So the idea of it being perpendicular, what this means is it forms 90-degree angles. And then, so it has to, so whatever segment or line or ray that we're talking about being a perpendicular bisector, it has to meet that segment so in a way that it's going to form 90-degree angles. Then the second thing it has to do is it has to divide the segment into two congruent segments. So for instance, if I just, let's put something up here that would not count as a perpendicular bisector. So this right here would not count as a perpendicular bisector of this segment because it's not forming 90-degree angles with the segment. This angle right here is not a 90-degree angle. It looks like an obtuse angle. This one right here is not a 90-degree angle. Looks like an acute angle. So that would not count. Even though it looks like it's kind of cutting this segment into two congruent parts, it's not doing the first part. It's not perpendicular to the segment. So let's get rid of that. Now this segment would also not count as a perpendicular bisector because even though it looks like it's forming a 90-degree angle right there, a 90-degree angle, it's not dividing the segment into two congruent segments. So that would not count as a perpendicular bisector. What a perpendicular bisector for this segment, what it might look like is perhaps something like this. Let me see if I can get it. Let's see here. That's not quite in the middle. Let me move that over just a touch. That looks a little bit better. So this segment right here would be a perpendicular bisector so long as it is making a 90-degree angle here, and then of course it would also make 90-degree angles at these other places, and it's dividing the segment into two congruent parts. So if I call this right here, if I call that point P, then segment AP and segment PB would be congruent. Then that would be considered a perpendicular bisector of my segment. Now the second term we're looking at, it's a little simpler, a little more straightforward. It's called an angle bisector. So this is some ray that's going to divide an angle into two congruent angles. So I have, let's call this angle ABC. So A, B is the vertex, and then C on this side. So this is angle ABC. If this ray, let me put a ray in there, if this ray right here went right up through the middle of that angle, so let's call that ray BD. If it went right up through the middle of angle ABC in such a way that this angle right here was congruent to this angle right here, then we would consider that to be an angle bisector. So I could say that angle ABC is bisected by ray BD, because angle ABD is congruent to angle DBC, right? That would be what it would mean if we said that angle ABC, yes, is bisected by ray BD. And so if I wanted to put some numbers to these things, if I said if the measure of angle ABC was, let's say, 50 degrees, then I could say that the measure of angle ABD and the measure of angle DBC would both equal 50 divided by 2 or 25 degrees.